My name's Dave, and I'm here to talk to you tonight about Constraint Layout. Okay? Now, just a quick show of hands. I've heard when we were in the crowd a little bit, how many folks would consider themselves new to Android development or not developers at all? Okay, that's a pretty good mix in there. Okay, whether you're new to Android development or not, how many of you have played around with Constraint Layout, maybe even just a little bit? Heard of it? Okay, good. All right, so now we're all kind of on the same page here. So what is Constraint Layout? Why do we care? Why am I even here? So for those of you who have done Android development for a while or even just a little bit, you're familiar with the idea that Android, in order to draw things onto the screen, helps you out to organize all of your views by giving you layouts. We call them layout managers, view groups. They have a bunch of different names, right? Things like relative layout, linear layout, frame layout. These are terms you've probably heard before if you've been around the Android SDK even a little bit, okay? So we've had a ton of these for a long time now, and recently, just at Google I/O here back in May, Google came to us and announced, we've got a new one for you. We're calling it Constraint Layout. And there's a couple reasons why you might care or why you're interested in Constraint Layout and you don't want to mess with necessarily any of the others. The first is, pretty soon, it's going to be the default layout that shows up in Android Studio. So when you create new views or new activities or whatever you're building in your code, Constraint Layout's going to show up whether you want it or not. Now you can go in and remove it, but it's going to be there kind of in your face. So at a minimum, you probably want to have some idea of what it actually does. Okay? In addition to that, and one of the reasons that they introduced it, is that Google is very bullish on the fact that Constraint Layout will be a very good way for you all to flatten your view hierarchies. Okay? Now, some of you may have no idea what I'm talking about, but the basic idea there is when you're building these layouts in code, the layout managers that we have today are very rigid. They're designed for very specific tasks. You know, linear layout lines things up top to bottom or left to right. Relative layout has a little bit of flexibility, but there are some constraints around what you can do there. And so typically what developers end up doing to achieve the layout design that they want is they stick them inside each other. That's what we call nesting. Okay? Nesting layouts is bad for performance in general. Okay? Now, I don't necessarily have any numbers or benchmarks or anything like that to show you, but just the general rule of thumb is the more you nest your layouts, the longer it takes exponentially to process and draw that code. Okay? So generally speaking, a good performance tip is flatten your view hierarchies to have fewer nested layouts whenever possible. Okay? Google seems to believe Constraint Layout is one way you're going to be able to do that. Okay? So if nothing else, that might be a good reason to pay attention because, hey, hashtag perf matters. Okay? So let's look at exactly what this thing is and what it can do. So Constraint Layout, let's break that down a little bit. So we just talked about what a layout is. Okay? And some of you have played around with this a little bit, so you may have some idea of how it works inside of the layout tools as far as moving views around. But how many of you would think just off the top of your head that you have any idea what a constraint is? Just throw out some guesses. What do you think they mean by constraint?
Rules anchoring.
Rules anchoring. What else? Minimums and maximums. Okay, we're getting closer. So it turns out, and this surprised me because I'm not really a math guy, but it turns out that the term constraint is a math term. It comes from solving systems of linear equations. Okay? And that is relevant because it turns out that that's how Constraint Layout does its work. Okay? So a constraint, in the way that Google is using the term, is essentially a mathematical expression given as a boundary condition to the objective function in a linear optimization problem. Okay, what does that really mean? At the end of the day, what it means is when you add rules, somebody said rules, to the views that you're putting inside of this container, internally, that layout is going to translate those rules into constraints, which are essentially just equations. Okay? And then it will use that system of equations to determine what the size and position are of all the views. The reason that this is important is, one, it's just fun to know. But it also means that constraint layout is extremely flexible because it really just boils down to a very complex set of math, okay? That luckily you don't even have to know how it works, right? It's just kind of interesting to recognize that fact. So basically as an example, what constraint layout sees when you put views in it looks something like this. So this is a very simple example of what constraint layout would evaluate if you put one view in and you just added a couple of rules to stick it to the top right corner. Okay? It's basically going to convert those rules into 4 equations for the left, right, top, and bottom of that view. Okay, what we call the bounds of the view. Okay? Now, in this case, that's fairly straightforward, right? I could look at that and we could probably even just do that in our head real quickly. It's not too terribly complex. But as you add more views and as you add more rules, things can get a little bit more complicated. Now, this is an example of still one view with only 4 rules applied to it, or constraints applied to it, okay? And in this case, it develops all of those equations to determine what the left, right, top, and bottom should be for each one of those individual views, okay? The best part is, you don't have to know about any of that stuff, but it gives you an idea of just how flexible that is, okay? Essentially, and this is defining the values associated with one view, like its right and left value, in terms of other components in that system that it has relationships with. In this case, the parent, which is what that P is for. Okay. Now, I'm in the middle of a blog post series right now on constraint layout, and if you want more details about how this works, follow along with that. Okay, because I'm going to go into more detail there. I'm not going to spend too much time on it here. Okay, but it's just interesting to know that when you add a bunch of views and you add a bunch of rules, that's actually what constraint layout is looking at. It's doing all of that math and it's solving that system of linear equations together. Now, interesting side note, it's using an algorithm called the Cassowary algorithm. Has anybody heard of that before? It's used all over computer science. Okay? So they didn't necessarily invent anything here. For those of you iOS folks in the room, Cassowary Solver is essentially what does auto layout as well. Okay? So that might be familiar to you. So that's all going on under the hood. We don't have to necessarily touch it, thankfully. So this is where constraint layout's magic kind of comes from. But let's talk about something that's a little bit more tangible in terms of how do we use it. So constraint layout is a layout, which means we put views in it. And then its job is to size and position those views on the display. So when we put a view inside of a constraint layout, it's going to get wrapped with a series of what are called anchor points. Okay? Now, there are a number of different types of constraints that we're going to look at. Not all of them are related to position, but the first block that we're going to look at right now are essentially constraints you can define that help you position views. Okay? So I'll just call them positional constraints. So when you add a view to a constraint layout, it starts adding anchor points where you can attach constraints. You can have vertical constraints, aligning where the top or bottom of that view should go. Horizontal constraints, such as the left or right side of that particular view. Centering constraints, you can say that 2 views should align their center points, whether it's horizontally or vertically, et cetera, et cetera. And all of these points are added to every view that's put inside of a constraint layout. And then your job as a developer is to make the connections where you want them to go. Okay? So for an example here, I've got a couple views inside, and 2 views are constrained together on the right and left side, and we've got another set of views down here that are constrained at the bottom and the top. Okay? In this case, essentially saying that those areas of those views should be aligned to each other. Okay? So the left side of this view should be aligned to the right side of that view, and it supports margins, so with some amount of spacing, et cetera, et cetera. Okay? So the first set of constraints that we're going to look at are constraints that allow you to position the views with relation to the parent container, as well as with relation to each other. Okay? Now, just something to keep in mind, it's not real relevant right now, but constraint definitions use IDs to reference between different views, which means you cannot attach a constraint to a view that doesn't have an ID. That includes the parent. So if I want to define a constraint between a child view and the parent container also has to have an ID. Okay, that was not necessarily true with relative layout, right? We had rules that said align parent something or other. That's not true anymore. And you'll actually see this if you play around with the visual layout editor at all. If you try to move a constraint to attach it to a view that doesn't have an ID, the layout editor will very helpfully add one for you. With a terrible name, it means absolutely nothing. So you typically want to put those IDs in yourself before you go around dragging things and making connections. But if you don't, because it's required, you'll see them getting stuck in there for you. So if you've ever wondered why, that's why. Okay, so what do those constraints actually look like? So those of you who have played around with it, maybe you've played around with the fancy new layout editor where you can drag arrows and make connections, and it's very nice and animated, and that's all great. But everything that you do in that tool will always boil down to some type of XML. Okay? So in your layout XML file, which does still exist, that didn't magically disappear, inside of your layout XML file, those constraints look something like this. Okay? So all those positional constraints that I just described on the last slide actually look like this when you're looking at them in XML. Okay? Not terribly scary. Right? If you've worked with XML layouts before, especially if you've worked with relative layout before, this doesn't look like a whole lot of magic. Right? You basically are defining a relationship between the view that has the attribute and some target ID. Okay? Nothing crazy. And those constraints are defined in terms of those same edges, bottom, start, and left, right, all of that. Okay? Now there's one that I left out, so I'll just quickly point it out, which is the baseline constraint. If you're not familiar with it, text-based views have an additional position called the baseline, which is essentially the bottom of the text as opposed to the bottom of the view. Okay? So you can align things based on that as well. You could do that with linear layout and relative layout as well. Okay? So nothing real too crazy there. All right, so let's take a look at an example. So this is a very basic example of what a layout would look like using Constraint Layout. And for assistance, I put a little rendering from the tool over there on the left. Okay, so nothing crazy. A couple buttons. We've got a button over here that's anchored to the bottom and the left-hand side, and then we've got another button that's anchored to the edge of that button, and then to the bottom as well. Okay, so each of those, if you can see them, little arrows in between, those are constraint definitions, and they're defined in the highlighted sections of XML. Okay, so again, it looks like a relative layout rule. Right? It's not too crazy to actually even write these things by hand. And to be honest, the more time I spend with this, the more I like just writing it by hand. Okay, but I'm an old fart when it comes to Android like that. So notice, though, that if we want to define these constraints where we attach a view to an edge of the parent container, we have to reference that ID. So just reinforcing what I said before. Okay? If your constraint layout doesn't have an ID, you can't attach anything to it. Okay? Just like any other view. Okay? But all these constraints here are really just aligning the view. Okay, we're just saying I want to basically line it up so that this edge and the parent are together and the two button edges are together, and that's just how they stick. And it does support margins, as I said before, so you can add spacing in between if you like. If there's no spacing, they're just going to butt right up against each other. Okay? So we look at all that, and congratulations, we've just reinvented relative layout. Right? We haven't really gotten ourselves anything. Everything that's being done here can be done with relative layout without too much effort. Okay? But we're not done. Okay? So what we're going to see is that constraint layout can do a heck of a lot more than this, which is why we can use it to replace existing layout managers like relative layout or linear layout, so that we can do everything in one layout instead of nesting them together for different reasons. Okay, so this is just the first example, but it gives you an idea to see how those constraints look in XML. So what if I wanted to do something like center a button? Again, something inside of the container, something I could do in relative layout. I could tell it to center vertical, horizontal, or just completely inside of the parent container. But I can do the same thing with constraint layout in a slightly more flexible way. So in this example, I'm still doing the same thing where it's being centered in the parent container. But because this is done with constraints on each side, and I'll talk about why that happens in just a minute, these constraints could attach to anything. I could center that in the parent, or I could center it between two other buttons, or a text view and an edit text. Anything that it's attached to, I can do the same sort of thing and center the view or place it somewhere inside that empty space using this constraint definition. So it's a little bit more flexible than what relative layout can do. Now, the way that this works is that by default, when you attach competing constraints in the same axis to a view, so basically I've got one on the left and one on the right, or one on the top and one on the bottom, okay? If I've got two constraints on the same view going in opposite directions, then by default, the layout will take that view and it will center it between those two anchor points, okay, whatever the two things are constrained to. Now, that's actually really nice in and of itself, because as I said, I can attach these constraints to anything. But Constraint Layout kicks it up even further by adding a new type of constraint called a bias constraint. Okay? So with bias constraints, I can adjust along that contention point exactly where the view should be placed. Okay? So for those of you who can't necessarily see it, what we've got down here is a couple additional constraints called bias, and the value is essentially just a float value between 0 and 1. Okay? It's a percentage of where along that line should the view actually sit. When it's not there, it defaults to 0.5, which is why you get exact centered right in the middle. Okay? But I could do something like this, where it's 0.25 in both directions, and it will shift to get that percentage up to wherever I place it. So now what we've got, on top of all these fancy relative layout-like rules, is this sort of super combination of gravity and weight built in as well. So now I can do the same sort of thing that I would do with gravity or with weight distributions in a linear layout using bias. And I can do it inside of the same flat layout that I might do my other relative constraints between views. Okay? So we're starting to get a lot more fancy features in here. Okay. So the other thing that relative layout is not the best at, and there are ways to hack around this, and I've done it before, is you can't really align something in a relative layout to some arbitrary point in space. Relative layout can only align views to the edges of other views. Okay? If you want relative layout to align a bunch of views to some space, one of the hacks that I've had to do is you basically take a view, stick it in there, it has no size, but you can put it at a certain spot and then you can align everything to that. Okay? That's no fun. So they have a solution for that in Constraint Layout as well. It's called a guideline. Okay? Now it's a little bit confusing because the guideline does actually show up in your layout. Okay? It's in the XML, but it's not, technically speaking, a view that gets drawn. Okay? It's just an arbitrary vertical or horizontal line that you can define with, in this case, a fixed distance from one of the edges. Okay, there's a couple ways you can define them, and I'll show them to you in a minute. But you essentially can define this guideline, and then this, just like the edge of any other view or the parent, becomes something that you can target from a constraint. So now, in the example here, I've got these two buttons, but the left edge of those buttons is aligned to a guideline rather than the edge of the actual container. Okay? So it gives me a nice clean spot that I can put anywhere in the layout to align views, whether it's center, left, or however you want to do that. It's just another target for all the other constraints that we're going to talk about. Now, I lied to you a little bit. It turns out if you dig deep enough, guideline is a view. But it's a very special view that has no size and is never laid out. Okay? So despite the fact that it does exist in Constraint Layout, it doesn't take any performance hit because it never goes through measure and it never goes through layout. Okay? So they've optimized that part of it out, but technically speaking, it is actually a view. If you were to iterate through the children in Constraint Layout, you would see it there. Okay? So the way that you can define these things is in three different ways. You can define a constraint to be aligned from the begin edge, and that essentially means that would be the left side for vertical and the top edge for horizontal. The end, which would obviously be the opposite. And in that case, both of those are provided with a fixed dimension. So like I had in the example here, it's 72 dp from, in this case, the left edge. Or you can define it as a percent. So the percent is essentially percent of that screen dimension, whether it's width or height, how far from the beginning edge do you want that guideline to sit. Okay? And then you can use that guideline as a target for any other constraints. Okay? So a lot more flexible than what we used to have. All right, so I want to take a quick step back before I talk about the rest of the constraints, and I want to spend a minute talking about measurement or view size, because Constraint Layout does things a little bit differently than you may have done with other views. It's mostly the same, but there are some differences. So there are 3 types of view measurement that you can define when you're working with constraint layout. You can wrap content. We've seen that before, right? Wrap content is not new. That's basically just going to measure the view to be whatever size it needs to be to fill out the content inside, whether it's text or an image or whatever. And you define it the same way, just allocating wrap content in XML. Fixed size, no changes there, right? If I just tell a size to be some particular dimension, it's going to do that, okay? The weird one is any size. So they've added this additional rule, which it turns out in XML is not that fancy. It's just setting the dimension that you're working at to 0. But if a particular dimension is set to 0, they call that defining that as any size. And what any size means is measure that view to fill up whatever the space is available by the constraints attached to it. So if we go back a couple slides to where I had the centered button, using competing constraints, you could take that view and you could place it centered between 2 edges. But what if I wanted it to actually fill the space between those 2 edges automatically? I can do that by setting that dimension of the view to any size. Okay? Now those of you who are experienced Android developers, what's missing? Match parent. There's no match parent. Why not? It turns out it doesn't work. For whatever reason that Google decided not to do it this way, if you attempt to size a view as match parent inside of Constraint Layout, one of 2 things will happen. If you do it inside of the layout editor, they just won't let you do it. If you try to set the size to match parent, they're assuming that you probably meant any size, so we're going to set it to 0 instead, which is actually generally true. Generally, if you were thinking that you wanted to measure the view to match, you were expecting it to fill. The problem with match parent, and I won't go into too deep of the details here, follow the blog post I'm doing, but the problem with match parent is it doesn't respect constraints. So match parent would always measure that view to fill the size of constraint layout, instead of filling the space between whatever constraints were defined. Okay? That has to do with the order of operations and the way they're doing stuff in there. But essentially, it's easier and apparently better for them to define a 0 dimension that allows them to evaluate the constraints first and then put the size on the view after they figure out how much space is there. Okay? So you actually can put match parent on a view at runtime if you put it directly into the XML instead of using the visual layout editor. What you'll see is the view is measured to be larger than it actually is drawn. And so you'll see the content shifted in weird ways, and it's behavior you don't want. So if you're working with constraint layout, match parent doesn't exist. Okay? Wrap content, fixed dimension, or any size. Okay? All right. Now I've got one more constraint that I want to walk you through really quickly. And I think it's my favorite. The ratio constraint. So this has nothing to do with positioning views per se, but sizing them. So they've added a constraint definition called dimension ratio that allows you to draw a view with at least one variable dimension, which is where any size comes in. So when you define this view, one of the sides, whether it's width or height, has to be set to 0 so that it can be considered flexible or any size. And constraint layout will do the work of measuring the other dimension and then ensuring that the flexible dimension is measured to keep that aspect ratio. Okay? So like in this example here, I have 2 image views, and I just want them measured at 16:9 and 4:3. Okay? No more square image view, aspect ratio image view, no more subclasses just to do this job. Okay? Yes, exactly. That's why it's my favorite. So now we can do all this directly inside of constraint layout, and we can do it for any view. I just picked image view because, let's face it, that's the one we all end up doing this with. Right? So now the trick here is, I'll just reiterate it, only one dimension can be flexible. Okay? If you fix them both, and wrap content from constraint layout's perspective is considered fixed. Because constraint layout is going to measure it based on what the view wants, not what it wants. Okay, so wrap content, constraint layout thinks that's a fixed dimension. So if you fix them both, this isn't going to work. Right? That logically makes sense. But the opposite is also true. If both dimensions are flexible, you also get really weird behavior. Now, I'm told that that might be fixed in a future version, but so that may actually be a bug. But I can tell you from experience it doesn't work. Okay. What ends up happening more often than not is that the sizing is right, but the constraints get screwed up. So things like bias aren't respected, and are just weird ways that you don't want to have to deal with in the real world. So ratio constraint. So you can kind of see at the beginning why I mentioned that really a constraint is just an expression, an equation that goes into this giant funnel that they go through and solve. Because they're not all about aligning view position, which is what most people think of if they just watch the keynote or something like that, because they saw them dragging arrows around and they saw the views move and everybody was clapping and it's great, right? Those were all about view position, but there are a number of different constraints that are already in here, and we'll probably see some more, in newer versions, that have really nothing to do with that. They have to do with size, or like the bias constraints that are somewhat about position, but not necessarily between relations and other views. So each one of these rules is what gets evaluated down to one or more equations in that giant system that I showed you. Okay? Everything that's labeled a constraint essentially has that particular job. Okay. Now I mentioned the visual layout editor a couple times. And I also mentioned that I don't generally use it a whole lot. I think that might be that primarily there are a significant number of bugs in it right now. It's probably good to point out, since I didn't at the beginning, that both Constraint Layout and the layout editor are both in preview right now. They're not considered stable released code necessarily, so it's expected that there are bugs in there. But in my opinion anyway, Constraint Layout is a lot more stable than the layout editor. So I tend to prefer doing these things in XML directly and not dealing with that tool just yet. But at the same time, they did release a brand new visual layout editor that makes working with really all the layouts that they have, but specifically Constraint Layout, much, much easier. As I showed you, the XML that's there is not terribly difficult to write, but it can get a little unwieldy if you have a lot of constraints. So they've provided a visual editor that allows you to do exactly the same thing by basically just connecting the dots on the views as you drag them into the layout. Okay, it works very nice. It's much better than anyone they've ever produced before. And I think Constraint Layout has a lot to do with that, because it's very difficult to define a visual editor with a rigid layout. Because you just want to put something here and it's going to snap over here. Okay, and those things just don't happen with the new layout editor. Okay? But there are two features that they've added that I just briefly wanted to draw your attention to, even if you have played with it, but you may not have necessarily messed around with. The first is there's an auto-connect feature in the visual layout editor. Okay? Now what this essentially does, if you have it turned on, because you can toggle it, is if you take a view and you drop it into the layout, anytime you do that, if auto-connect is enabled, it will automatically try to evaluate where you placed it and hook up the constraints for that view so that it stays there. Okay? So it can be helpful because you don't have to actually drag each of those individual arrows yourself, but it's a little, let's just say, dumb in the way that it chooses the things that it wants to connect with. It pretty much always will choose what's closest to it, okay? Which in a lot of cases is probably correct, but not always. So just be aware of that. And if you're going to use the auto-connect feature, when you drop that view on, you're going to see those constraints get automatically, and they're going to animate out with nice little arrows to the views that they're going to, but it'll always hit whatever's closest. Okay, so if that's not what you were expecting, you'll probably spend more time deleting constraints than adding them this way. Okay. One of the nice things about it, though, is it doesn't mess with what's already there. It only does this when you drop a new view on, and it only applies constraints to that view. So it's not going to mess with whatever else you already had in the layout. Okay. The one that I think I like a little bit better is the inference feature. This one is actually really smart, and it seems to be getting smarter with each version. What this will do is it will evaluate the entire layout, all the views that are currently in it, and it will automatically add constraints across the whole thing. So if you don't want to add any constraints, you just want to place the views where you think they should go, you want to click one button and have it all done for you. That's inference. Okay. The nice thing about this is, just like with AutoConnect, inference will not mess with constraints that are already added. So let's say, and that's why I say here that it works really well if you do this in small iterations. You could literally put all your views down, click it once, and have the entire layout inferred. But what I think works a little bit better is to do one section of your layout, then infer that, and then do another section of your layout, and then run inference again, and it'll just update those pieces. Again, it won't clobber the constraints that you've already placed. It will only update the new ones. Okay? So if you were doing some work over here and you got it set exactly the way you wanted to, you can still trust that if you run inference for these views over here, it's not going to mess that up. Okay? So it works really well to do in small batches, and it doesn't cause any problem. So you might want to play with both of those if you're just getting used to the tool, because it's interesting to see the decisions they try to make for those particular setups there. So if you're looking at the XML that's defined by the tool, if you're using the Visual Layout Editor, you'll see all the attributes that I've already shown you. But you'll also see sprinkled in a lot of these things. Okay? Now, those of us who've been doing this for a while probably recognize the tools namespace as something that doesn't happen at runtime. But for those of you who may not be familiar with it, I just want to point out, because there's a lot more of this littered in your code than ever before, this stuff, primarily these three attributes, will be added by the layout editor so that it can internally track what's going on with some of these features. So for instance, when I drop a view onto the layout and I drag it around, it's not going to snap to weird places anymore. It's going to stay exactly where I put it. The way that they are able to do that is they track the position of where I dropped it in the XML. So there's a lot of additional metadata in here that has nothing to do with what actually happens at runtime. But it's there so that if I close the layout and open it again or whatever, the view is still where I put it. Okay, so absolute X and Y will show up if you're dragging views around. This last one down here, the creator attribute, you will see pop up into your XML if you're using AutoConnect or inference. You'll see this with whatever the particular anchor point is associated with that constraint. So it'll say, you know, constraint bottom creator or constraint top creator. This is applied when that constraint was added by AutoConnect or inference. So the layout tool can track whether they created the constraint or whether you created it manually. And the ones that you create manually, they won't touch. The ones that they created, they think are safe to destroy and recreate using something like inference.
So that's the answer to my question.
Yes. Yeah. So if you go diving into the XML, you'll see these show up, those creator attributes. And those primarily exist just so that the layout tool can track what it's doing and make sure that it's not messing with changes that you made yourself. Okay? All right. So that's sort of the gist of it, right? In general, you look at all those constraints that are available to you to position views, size views with ratios, fill space, all of that. And you've effectively got relative layout, linear layout, grid layout smashed into one. Right? You can do anything you could have done with those inside Constraint Layout. And because it essentially has the features of all of them, you can, at least in Google's opinion, and I think I tend to agree with them, you can pretty much in every case take nesting out of the equation and do the exact same thing with some amount of constraints, whether you do them manually by hand or whether you let the tool try to do it for you. Okay? So a couple other things just to keep in mind. I do have a sample repo that I just post with some examples of essentially different types of layouts that something you might have done with linear layout or grid layout and how it's done with constraint layout instead. So the layout pancake repo is on my GitHub, and all my GitHub stuff is at milehighandroid.com, so it's easy to remember. If you are interested in some of those gory details that I mentioned I am in the middle of a blog series, so you can follow my blog, Wires Are Obsolete. And the first post went up today, and there will be another one probably in about a week or so. If you are one of those math nerds that's really interested in what is happening with those linear equations, there's a really cool site that's dedicated to cassowary solvers. And so you can get more information about how that works, implementations in C++, Python, Java, whatever. Right? So there's a lot of that information there. And one thing that I didn't really go over that I think my colleague Mark Allison does really well is a lot of the user-facing features in the layout editor. So if you're curious more about the visual editor and some of the finer details of that, he's still going through a series on styling Android that does a really good job of going through those details as well. Okay? All right. So that's all I have for you guys. Thank you for your time. If you have any questions, I'm more than happy to answer them now. Otherwise, thanks for coming.